Hi, welcome to the last section of this chapter, Lesson 6. Today we're going to learn about parametric equations for conic sections. Now for Cartesian form, the unit circle is x squared plus y squared equals 1. In parametric form, we're going to write x equals cosine t and y equals sine t. And we have to look at our window and make sure our t goes between 0 and 2 pi for radians. And let's keep it in radians. If we were doing it in degrees, we'd go from 0 to 360, but let's keep this in radians. Alright, so graph the following on your calculator and look for the center of the circle. Alright, hopefully you saw that the center was at 2 and negative 5. So if I wanted to write this out in Cartesian coordinates, I would say x minus 2 squared plus y plus 5 squared is equal to our radius squared, which is just 1. Now graph this out. 2 cosine t in the x, 5 sine t in the y. Hopefully you saw that that was a graph at 0, 0, and it stretched 2 in the x direction, 5 in the y direction. So it would be x over 2 squared plus y over 5 squared is equal to 1. Now see how this is an ellipse, stretch 5 in the y, 2 in the x. Same thing here, stretch 2 in the x, 5 in the y. So if we wanted to do this without a calculator, our center point would be these numbers here, 4, negative 1. Our horizontal radius we would look for in the x direction, so that's the x stretch. Our vertical radius would be in the y direction. So just from here we can sketch our graph. Nope, that's not the one I wanted. Let's get rid of this. And I'm going to go 4, 1. 1, 2, 3, 4. Down 1. And in the x direction I'm going to go 3 to the left, 1, 2, 3. 3 to the right, 1, 2, 3. And in the y direction we go 5 up, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And hopefully you can see that this is an ellipse. There you go. I drew it kind of poorly, but hopefully you can see what's happening. Now if I want to make the Cartesian equation, x minus 4, because it moves to the right of 4, the horizontal radius will be underneath, which is 3, squared plus y plus 1, move it down 1, over 5 squared is equal to 1. Now try this one on your own, pause the video, and see how well you do. The center is 3, negative 1. My horizontal radius is 4, my vertical radius is 2. If I sketched my graph, we're going 3 to the right, 1 down. Horizontal radius is 4. Vertical radius is 2. And now we have a nice ellipse. Now the parametric equation for this, since this is in standard form, we want to go back to parametric. X will be 3 plus 4 cosine t. The y will be negative 1 plus 2 sine t. Alright. So the general parametric form for an ellipse or a circle looks like this, where the center is at hk, the horizontal radius is a, and my vertical radius is b. Now for our unit hyperbola, if we have x squared minus y squared equals 1, it'll be x equals secant, y equals tangent. If the negative is on the x squared, we just have to flip these around. So the secant is with the one that's positive. And that's important because that's the direction the graph is going to go. So in this case, the center, same transformations as before. The center is at 3, -2. The slopes of the asymptotes is going to be positive, negative. These two numbers, the y number over the x number. But in this case, it's just going to be 1 over 1, which is 1. Now, which direction does it open? Well, since this is secant, it's going to open in the x direction, so it's going to open right, left. So let's sketch this graph. We're going to go to the right 3, down 2, and our slope is going to be positive -1, which is a nice slope. And so now we can, we know it's going to open to the right and to the left, so we're going to go 1 to the right, 1 to the left, and now we can draw our hyperbola. If I was going to write this Cartesian equation, I would have to say this is x minus 3 squared over 1, and then that would be minus y plus 2 squared over 1 equals 1. Now those over 1s don't really do anything, so we could just say x plus 3 squared minus y plus 2 squared equals 1, and that would be probably better. Alright, now try this one. Our center is at 0, 0 because it doesn't get moved to the left or to the right. The slopes of our asymptotes is our y stretch over x stretch, so plus or minus 2 over 3. Since the secant is in the y, it's going to open up, down. So to sketch this graph, it has a slope of up 2 over 3 and down 2 over 3. So these would be some points on my asymptote. Now it opens up, down, so I'm going to go up 2 and down 2, and then draw my hyperbola to my asymptotes. There we go. Now if we want to make the Cartesian equation, it'd just be x over how far we moved in that direction, which is 3 squared. And that would be a negative, and our y would be positive, and it would be y over 2 squared now equals 1. Alright, now let's start in our standard form and get our parametric equation. Our center is going to be 2, -1. The slopes of our asymptotes are positive, -3/2. Since this is positive, it's going to open left, right. And the parametric equation is going to be x equals 2 plus 4 cosine, or not cosine. It's opening left, right. So this is going to have to work with the secant, and y is equal to -1 plus 3 tangent t. So we have our equation. Alright, so here is our situation, and we can either have it like this, or we can have it like this, where our center is always at hk. The slopes of my asymptotes is plus or minus my b over my a. And over here, since secant is here, this opens right, left. And over here, the secant is on the y, so it opens up, down. Alright, Now we want to solve for cosine t sine t, and then use Pythagorean theorem identity to show how the parametric equation transforms into the Cartesian form. Alright, so let's solve for x and y. So over here, if I solve for cosine t, it would be x minus 3 over 2 is equal to cosine t. Over here, I'd have to add 1 and divide by 5, so it would be y plus 1 over 5 is equal to sine t. Alright, and now I can square both sides of both equations. Because if you do something on the one side, you have to do it on the other. And now let's just add straight down. So I'll have x minus, so here I should write add over here. X minus 3 over 2 squared plus y plus 1 over 5 squared is equal to cosine squared t plus sine squared t. And now what's sine squared plus cosine squared? It always equals 1. So we have x minus 3 over 2 plus, or squared, plus y plus 1 over 2 squared. Alright, so this got us to our Cartesian equation. Sometimes people ask, well, how come in these equations this moves it in the opposite direction that you think? X minus 3 moves it to the right, and y plus 1 moves it to the left, or down. And the best answer for that is parametric equations do exactly what you would think they should do. But when we solve these and bring it into Cartesian form, and Cartesian form we're more used to, when we bring it into Cartesian form, it modifies this so it doesn't work how we want it to. And you can see here when we had to solve for our sine t and cosine t, we subtracted 3, and that's how we got x minus 3. Alright, here is a good way to organize it. If this helps, pause the video, write it down. If not, you can start on your homework. Good luck.